Hello guys, thank you for tuning into my channel. If you are new to this channel, please don't forget to subscribe. Please subscribe this channel, and I need your help because this is a free video. So if you subscribe, I'll get that support from you. So today I'll show you how to draw the stress strain curve, basically the concrete damage plasticity data, how to get the concrete damage plasticity data for any grade of concrete that you are using. So we'll be using this paper here. If you have the experimental stress strain data, then you can use it directly, but if you don't have, then we need to use some model. Like here we'll be using Kenton-Park model to obtain this compressive as well as tensile behavior. So let's go through it. Now you see, Kenton-Park model says that the ultimate stress occurs at a strain of 0.002. Sigma cu is ultimate stress. That is, let's say if you are going for M30 or B30 or whatever code you are using. In IS code we usually go for M30, M20. So if you are using M30, then sigma cu is your 30, and 0.5 sigma cu will be 0.5 times of that 30, and the sigma cu, like at 30, like 30 M30 at 30 Newton per mm square, the strain will be corresponding to this value 0.002. so you will be using this model. So these are the formulas that we have. So there are two. If you see this curve, there are two type of behavior. Up to 0.002 the curve is parabolic, and after that it has some other behavior. So this behavior is defined using this equation. So we have written this equation over here in this Excel file, and we'll use that one accordingly. Now I have entered this value. So here we'll try to calculate for M80, and these are default values. You don't have to you don't have to play with this. These are usually determined with experiment, so you don't have control over this data, and remaining values will be calculated. So first we will calculate the strain, then we will calculate inelastic strain. Let me explain you the difference between the strain and inelastic strain, this elastic strain and inelastic strain. So all of us know, we have gone through this type of stress strain curve for any material. Let us draw it for concrete. Will be getting similar to this. Now see, there will be some yield point. After that there will be some elastic point, and after that inelastic behavior starts. So let's say this point is up to this point the material is elastic. So what will be the strain at this point? Let's say if we are starting for 0 and the strain is 0.002. I'm just giving an example. I've taken a random value 0.002, here 0.003. Likewise, the x-axis is representing strain and y-axis representing stress. So this point is elastic point. So up to this point, up to the strain 0.002, the strain is elastic strain, and after this point inelastic strain starts. So this portion is elastic, and this portion that I am marking, this is inelastic. So this point is elastic strain. So what will be the inelastic strain over here? It will be 0. So if I write the total strain 0.002, 0.003, this is my total strain I'm writing. And if I have to write the inelastic strain, this is inelastic strain, inelastic strain. So up to 0.002 the strain is elastic. So what will be the inelastic strain over here? It is 0. Why? Whatever strain you have, see, beyond this point the inelastic behavior starts, and up to this point we have elastic behavior. So at this point, though the strain is 0.002, this strain is elastic strain, and inelastic strain will be 0.002 minus this strain will give you 0 value. That's why we'll see in Excel file while calculating. So that's why first I'll calculate the total strain. this will be my total strain. So let us assume some stress. So this will be based on your desired number of data point. You can select random stress values. So let us take stress value of 0, then how much shall I take? Let us take the more data point you take, the more time will be required for you to calculate. So what I can do, if I use this model, if I use this Kent and Park model, so they basically saying that your elastic strain is up to 0.5 sigma Cu. So 0.5 sigma Cu, up to this point the behavior is elastic, and after that inelastic behavior start. So no significant of calculating this value, because if I start from 0 to 4, let's say I want to calculate for M20. I'm just giving you an example. If I have to calculate for M20, so what I have to do, 0 to 4 like that, I have to go up to 20. Okay, so what Kent and Park says that M10, 0.5 of 20, here sigma Cu will be 20, so 0.5 of 20 will be 10. So up to this point your behavior, this much behavior is elastic, and after that this point inelastic behavior starts. And the data we need in concrete damage plasticity is yield stress and inelastic strain. So even if you are calculating the values beyond this value, like for B to M20, the values previous to M10, 0.5 FCK we are considering inelastic behavior, that this one I have considered 0.5 sigma Cu. So no point of calculating all these values, because that will be complete waste of time. That's why we are directly starting from inelastic stress and inelastic strain. So we'll directly start from inelastic stress. So here we are going for M80, so sigma Cu will be my 80. Okay, now 0.5 times 80, 0.5 times 80 will be my 40. So just avoid these values, because this I have written just to explain you. So after 40, you take any random data, number of data point you need. Let's say I am taking it at a gap of 5, so I'll go up to sorry, there is some formula, so I need to delete it. Why this is happening? Oh, sorry, 45, 50. Just take random values up to M80, and after that the value will decrease. See, if you see this model, up to 80 sigma Cu is my 80, because we are going for M80. So this value is sigma Cu, this value is sigma Cu, and after that the stress is decreasing. So I'll have to decrease the stress. Let us go for again 75. Same, I'm just keeping same configuration, same gap. You can reduce it, no problem. You can take any gap, any what is called, any value over here. Like this will be increasing up to 80, and after that it will decrease. So instead of 5, you can take a gap of 2, like it will be 42, or it will be 44, like that. Here I am keeping a gap of 45. Now what I have said, that at total value of sigma Cu, what is the strain corresponding? 0.002. So 0.002. So I have got this. Now this total strain I have to calculate. Remember, this is my total strain. This is not inelastic strain. This is my total strain. Now for 40. Now how to calculate the total strain? Using this formula. Here if you see, sigma C is the strain that we need, and sigma dash Cu is my value of 0.002, and sigma Cu is the value of 80, and we have to calculate sigma. We have this value sigma C. So for sigma C equal to 40, sigma C equal to 80, and 2 into epsilon C. So epsilon C will have to calculate, and epsilon dash C is the value of 0.002. So if I write, if I insert the symbol from here, it is very difficult. Oh, okay, I got it. And epsilon, and I'll write C, and I'll keep it in suffix. Okay, epsilon C, and I need also a dash, epsilon C dash. So this value is given as 0.002. This has been given over here. I have taken directly from this. This data is given over. So this one, if we simplify this, so this is a quadratic equation, right? This is a quadratic equation, and if we simplify this, then it will simply if you consider this as x. So how you are writing? This is my x square, this is my x, right? So this is how you can simply solve this equation to get sigma C. So this is a quadratic equation. Okay, so next, this equation has been simplified and written in this form. So as I have said, epsilon C dash is 0.002. So I have simplified and written it in this form, and this is a quadratic equation. So to solve it, just go to Google, simply use Google and find a quadratic equation solver. Let's get a quadratic equation solver. Okay, so A, B and C. So it will simply give me the roots. Okay, this is a better calculator. Let me check. 3, 5, 2. Okay, yeah. So this will give me simply data if I simply enter over here. So here the data that we have, we will mark this one, this part as A, and this part as B, and this part as C. So the equation becomes A epsilon C square plus B epsilon, avoid my writing, epsilon C plus ABC equal to 0. This becomes my quadratic equation. So here in this calculation sheet, I have marked A, B and C values. So let us correct these values. These are the older values I have calculated again. So now you see what is my A. A value is minus 1 upon 0.002 square. So that value is given by this. B value is 2 upon 0.002, and C value is epsilon C that I have to calculate. Here epsilon C will be my 40 and epsilon Cu will be my 80. So let us check A12. Okay, A12 is correct, and J7, This one is my J7. Okay, so this calculation is perfect, and the multiplication will be minus. So this data has been calculated. Now this one will be A13, A14, A15, A16, A17. It will be -1, and likewise I'll have to calculate it up to this point. Okay, I've got all this data. Now I'll simply enter one by one, and I'll get the data, and I'll enter the total strain over here. So A value is -25,040. 2540. So I'll bring this calculator over here. Just enter the value -25. 1 2 3 4 0. Sorry, one more 0. Then B value is 1000, and C value is my -0.5. Now check, there are two roots. This one is 0.0034, and this one is 0.0058 something. Now which one we should be taking, whether we will be taking this one or this one? Now just use your common sense and tell me. Here all this strain, this one shall be less than 0.002, and all the strain value over here will be greater than 0.002. So those values, among these two value, the value which is less than 0.002 will be entering over here up to this. Okay, so I'll mark it with some color. Okay, all these values shall be less than 0.002. So we have got two roots, and out of which one shall we do? We should be taking this one. This is my strain value. So let us take up to 4 digit only, or you can take up to 6 digit, no problem. Or let us take whole value. What's the matter? What's the deal in it? You can take all this value. So this is my data. Next, for M45, so these will remain same, only this one will change. So copy this, because this one, see, this is A13 upon J17. So A13 is my this, and J17 is this. So I have kept it constant. Use the $sign to keep it constant. So simply go over here and paste it, this one. So again here we'll be using this root. So keep calculating like that. Next value is this. Just change this value, and you're getting the data. If you use such a calculator, it becomes easier. 0. Okay, parallelly we'll mark it, so that at least we can understand that we have taken these values. We will not have any problem. And next is my this value, so I'll mark it red and paste it over here. Sorry, may not have copied. 7, 5. Yeah, this is the value I'm getting. Mark it red and copy it. All the values which are less than 0.002, I'll take that values only. Mark it red and copy it. You can directly make an MATLAB code also for this. Mark it red and copy it. Okay, so I've got this value. Now just check it for -1. It should be 0.002, and this is a cross check. If you are not getting this value, that means your answer is wrong. So only one root, 0.00. Now for values greater than this, we'll be taking the strains which are greater than 0.002. So yeah. Next is for this. I've forgotten to mark it right, because if I mark it right, it becomes easier. See, I'll not take this value because I need now strains greater than 0.002. I'll mark this red. The more data you take, the more difficult, not difficult, it's a labor job. You'll have to do it multiple times. You'll have to enter it. Did I make any mistake? I just want to check it for this once. Do I have made any mistake? 0.311 is missing. 0.311 is missing. Yeah, I have made a mistake, because see, this data is for one previous, so these data should be here. Let me just check it. 0.2866. 0.28, yeah, that's correct. For this, it should be 0.003. Yeah, it's correct. Then for this, it should be this one. And for this, it should be yeah. Now for 5625, this is the data, and for 0.5, this is the data. For 4375, and for 375. This is the data. If you want, you can go for M25 also, but I'll not go. No, just leave this data. Now if we plot the stress strain data, here x-axis will be stress. Okay, if I plot it, this will be reversed, because usually we take strain in x-axis, but here the stress is taken in x-axis. So what I'll do is, rather than doing this, if I just change this, just for plotting I'm changing, don't worry, just for plotting, don't consider this, just for plotting the data I'm checking. do you have made any mistake over here? Up to 70, like at 70 it is okay. Let me check it for this 0.875. 0.875. What is the data? JS7 A22. A22. Just let me check once. 0.875. 0.875. The data should be this one. 0027. Yeah, it's correct. And after that, this one 0.00286 65. Why is going like this? For 75, 70 and 75. So for 70, 2728. No, there is some issue because the strain is okay, no problem. Up to 70 is correct. 0.00129 up to 70. Okay, there is some issue with this. 40, 45, 50, 55, 60, 65, 70, 65, 75, 80. Okay, sorry. If I plot it up to 80, 70, 75, okay. Here there is any issue. Now it cannot be same. We have definitely made a mistake. So for this A19, we have made a mistake. Strain is this. Maybe 0.002. This one. Yeah. Now it's perfect. For A75, we entered the data 9375. Yeah, and this one, these data will be just previous, because see here we have made a mistake that all the data, like for 0.5, one row behind, it is for 40. 0.5 is 40. So I'm marking, if I'm marking for 70, that doesn't mean 0.8125 is for 70. 0.8125 is for 65, and 0.875 is for 70. So just let us check with. So this type of silly mistake you should not do, like me. So just avoid. Yeah, this is correct. That's why you should always plot the data. Once you plot the data, you'll definitely understand whether your data are correct or not. Now see, this is the stress strain curve for concrete, and this point will be a linear point, so there is no point of getting this data. Now up to this point, our behavior is elastic. Which point? Let me mark this point, the first point. The behavior is elastic, so after that we will get inelastic behavior. So for that I've just used this one to plot the data. Now I'll go back, I'll not go back, just write in elastic strain. Inelastic strain. Now what will be the inelastic strain? This is my elastic strain minus this, and this will be constant, so I'll make it constant. Sorry, yeah. So this is basically, if I copy this data, so this is basically this one, nothing else. B12 means this one minus the same data, and if you do like this, so this is the strain. So this one minus this one minus this one minus this, likewise will be getting. So this is my inelastic strain. So parallelly I'll again copy this, and parallelly I'll keep writing the exact data that you need for concrete damage plasticity, so it becomes easier for you. We don't need, so we need inelastic strain. So yield stress will be this, simply sorry, we have the yield stress up to this, and inelastic strain will be this one. So this is my yield stress and inelastic strain. Now damage parameter and inelastic strain. Now see, damage parameter over here, if I show you this graph, these values, you see damage parameter is 0 up to a certain value. Over here also you see directly 0 up to a certain value. Now what is that value? That value is the ultimate yield stress, the ultimate stress. That is, up to this point your damage parameter will be 0. What does it mean? That till the stress has not reached the yield point, the damage is not started. Sorry, ultimate point, the damage is not started. So what is the ultimate point we have? We have the ultimate point 80. So up to this will be entering 0 0 0. That implies the stress, the damage has not occurred till the stress has not reached ultimate point. This is sigma Cu. Sigma Cu is 80, and after that damage is started, an inelastic strain will be same that we have calculated for all. You don't have to worry. Just here you'll have to calculate the damage parameter for these values. Now how to calculate? You'll get directly over here. See, this is the sketch, and how to get it. See, sigma T and sigma C, and from here you can directly estimate the damage parameters. Now you can use either of these values, okay, and epsilon naught. So epsilon naught, see, our IS code, IS 456 2000 says that epsilon naught is 5000 under root FCK. So you can use this Young's modulus as 5000 square root SQRT FCK. FCK is my 80. So this is my yield stress, modulus of elasticity. This is my modulus of elasticity, that is 44,721. Young's modulus that we have got using 5000 under root FCK. This is for IS 456 2000. Now, if we use the simple formula of stress upon strain, that is, this is my yield stress upon yield strain up to elastic point, it is getting 68,000. Now, which one shall we take? So, as we are using this Kent and Park model, so I would suggest you to use the stress upon simply stress upon strain. The whatever modulus of elasticity will be getting will be using that only, because if you use any other formula and from any other code, it may give you wrong result, because if you are using a particular model, then you should be using that one only to calculate the modulus of elasticity, that is stress upon strain. So will not consider this value, will directly use this one. So what will be the Young's modulus, and this is also the value of E naught. It is equal to stress upon strain. So this is my modulus of elasticity value for M80, that is 5000 square root FCK. Now we need the damage parameters. So to get the damage parameters, just enter the inelastic strain values, and damage parameter it will be 0, 0, 0 up to a value of M80, and after that simply find out sigma T and sigma C. So to calculate the damage, these are the sigma T, sigma C value. Now it has the paper has simplified and given a formula. DC is damage in compression. So 1 minus sigma C upon sigma CU. Sigma C we know, and sigma CU also know. Sigma CU is 80 and sigma C is the corresponding stress. So this formula I have also given over here. So let us calculate 1 minus sigma C, sorry, 1 minus sigma C is my this upon sigma CU is my 8. That's all. Okay, so these are your damage values. Now one more thing I need to tell you, that here Poisson's ratio, you know, for concrete it will be 0.2. Now this is my modulus of elasticity value. So this is the damage parameter. So the complete compressive behavior has been obtained. So yeah, we need these values. So this is my complete behavior, compressive behavior, damage parameter in elastic strain. Now tensile behavior. For tensile behavior, they have simply given this model. We can use directly this model to get the tensile behavior. So for tension value over here, you can see here they have used only 2 points, because they are simply taking the 1 point at the peak and followed by one more point. So we'll not use this data, we'll use some other paper. So this is the paper that I am referring. you can directly go to this graph, refer this graph. Here the maximum tensile strength will be this FCT max, then 2/3, 3/3 and 1/6 of FCT max, followed by this string. Now let us just make a table over here, yield stress. So tensile behavior, yield stress, so maximum FCT max, first one, FCT, not this one, FCT max. FCT max, what will be? It is usually 0.7 under root FCK, right? 0.7 SQR square root FCK. FCK is my 80. So sorry, I'm calculating it wrong. It should be calculating over here. 0.7 square root FCK. Yeah, so this is my tensile strength of the concrete. And next value will be my, what is the next value? It is 2/3 of FCK, then 3/3 and 1/6. So it will be 2/3 this multiplied by 2 divided by 3, and again this should be multiplied by 3 divided by 8, and again this should be multiplied by divided by 6, because if you see it is 3/3 of FCT max and 1/6 of FCT max. So we have got our yield stress value. Now strain, total strain. So total strain we can directly find out using stress upon strain formula. So what will be the first strain value? Epsilon CR. We have this modulus of elasticity, so it will be stress divided by modulus of elasticity. So this is my first strain value, and corresponding strains will be this one, 3, 5.875, 10.5, 3, 5.875. So 3 into this, just I'll copy this one, just or just make this one constant and drag it over. Now just correct it. It will be 5.875, this one, because this one, sorry, 3 CR is already we have calculated. 5.875 is for 3 CT, 3 by 8 FCT max. 5.875 is 5.875. Next is for 10.5. And that's all. If you need, you can go for 0 also, no problem, but over here will not, for 0. Now this is my total strain. Cracking strain will be this minus this value, and this value shall be constant. So this is my cracking strain. And damage parameter, so cracking strain, here again it will be same, cracking strain will be same. And damage parameter, the equation that has been given over here, dt, yeah, 1 minus sigma t upon sigma t naught. So again 1 minus sigma t, this is my sigma t upon sigma t naught. This one, sigma t naught is my the same value, that is my maximum value, sigma t naught. So this will constant, this will be automatically 0. And so if you see this graph, at peak point, until unless peak point is reached, the damage will be 0. So see, the peak, well, the damage is 0, then the damage has started. So this is how you calculate. I'll simply copy this data, sorry, over here, yield, stress, I don't need this. Yield, stress, then cracking strain. I'm just arranging this value, nothing else. And then damage parameter and cracking strain. So even if I just copy it, just special values. Okay. So these are my values. Now if you need more data, you can calculate, you can go for any other model, and from there you can use this data, and these values will be always constant. It will not change. There is no change in value. And modulus of elasticity, here we have obtained as this stress upon modulus of elasticity, we have obtained as stress upon strain. This is my modulus of elasticity value E naught. So thank you for watching this video, and please don't forget to subscribe and share it with in your college and with your friends, those who need this. And that's all. If you need this Excel file, do contact me. I'll give you this Excel file. There will be some charges, but it is already visible. Everything is visible. So if you need any help, do contact me. And thank you for tuning into my channel, and please don't go without subscribing.